Assalamu alaikum and welcome to Cambridge Chemistry channel with Sarwat Ahmed. I will be solving paper 4-2 from October-November 2020. If you like this video, please subscribe, like and share this video. So let's start. A student investigates two different aqueous electrolysis using the apparatus shown. This is the apparatus shown. This is the apparatus of electrolysis. Just wait. A student investigates. Question number 1 is student investigates two different aqueous electrolytes using the apparatus shown. Carbon anode, carbon cathode, aqueous electrolyte. Dilute sulfuric acid. We know that if the electrolyte is dilute sulfuric acid, it has H positive ion, sulfate ion and OH ion. So name of the product: at anode OH ions discharge to form oxygen gas. Name of the product: oxygen gas. Then bubbles of the observations at anode will be bubbles of colorless gas, because oxygen is colorless gas. Aqueous copper 2 sulfate, aqueous copper 2 sulfate with carbon electrodes. Because we are using carbon electrodes, the ions are Cu2 positive, sulfate ions, H positive and OH ion. And the at anode, same hydroxide ions are discharged to give oxygen gas at the anode product. Oxygen and bubbles of color. And at cathode, because copper is below than hydrogen in reactivity series, so copper discharge at the copper ion discharge to form copper solid at cathode. And observations at cathode will be pink solid. State the test and its observation to identify the hydrogen gas. Test: take lighted supplant in the near the gas jar. Supplant in the gas jar. Hydrogen gas produces pops in flame with lighted supplant. Question number 2. When solid group 1 nitrates are heated, they decompose and give off a gas. The gas relights a glowing supplant. This is the oxygen gas which relights the glowing supplant. The name of gas is oxygen. Oxygen relights the glowing supplant, and hydrogen gas produces pops with lighted supplant. This is glowing supplant and that hydrogen with lighted supplant. It is important. A student investigates the rate of decomposition of 4 group 1 nitrate. The student heats each of the nitrates separately with a Bunsen burner. The student measures the time taken for a glowing subflame to relight for each. You know that group 1 nitrates are first 4 LiNO3, sodium nitrate, potassium nitrate, and rubidium nitrate. This is group 1 nitrate. So it is important to control the amount of heat supplied by the Bunsen burner. So just 2 ways the amount of heat supplied is kept constant. Gas tap turned on by same amount. On this is first and second flame or heat is the same distance from the test tube. Suggest a variable involving the metal nitrates that should be controlled. Same intensity of flame. We can write down same flame or same intensity of flame can also be intensity of flame or burner. So suggest a variable involving metal nitrate that should be controlled. Same amount of solid or same moles of metal nitrate should be used. Now next, lithium nitrate. Each experiment is repeated 2 more times. The results are shown in the table. Lithium nitrate 100, experiment 100, time taken for the glowing subflame to relight. Experiment 100, 150 and 100. So taking this reading and this reading because these are the same, and the average time is 100. And experiment in this for potassium nitrate 300 and 320, and which 320 get 310. Similarly, radium nitrate 400, 450 and 410 and 400 and 410 can be used. 2 is equal to this is 405, and similarly 200 same amount, so we are using these 2 reading divided by 2 is equal to 200. So use the time in the table to calculate the average time for each metal nitrate. Do not use any anomalous times. Write your answers in the table. lithium nitrate, right your answer, lithium nitrate as the average time is smallest, as time is smallest. Which metal nitrate decomposes the fastest? Use information. So sorry, this is not this one. Write your answers in the table. We are write down, we take anomalous, we are we are not using this value because this is anomalous, we are not using this value because this is anomalous value, and we are not using this value because this is anomalous and this is anomalous. So we are taking the average that it is written in the table. Which metal nitrate decomposes fastest? Use information from the table to explain. Lithium nitrate as average time is smallest. And down the group reactivity of metal compound is increases. Reactivity increases downward, stability increases. Compounds become more stable downward. So when compounds are more stable, so more heat is required to break down. So question number 3. Name a piece of apparatus used to measure 25 centimeter cube accurately. A student is provided with solution K, which is sodium hydroxide. The student determines the concentration of K by titration. The student measures 25 centimeter above K and transfer it to the apparatus A. Pipette. Name apparatus A. This is volumetric flask. Volumetric flask. The student make up 25 centimeter cube sample of K to 500 centimeter cube of distilled water. This is solution L. The student transfer 25 centimeter cube of L into conical flask and adds 2 drops of methyl orange indicator. Solution M is 0.0500 mole per dm cube sulfuric acid. M is put into the burette. Sulfuric acid is taken in burette and run into the conical flask until the indicator changes color and the end point is reached. Why is it wrong to wash out the burette with distilled water immediately with filling it with M? It dilutes the acids. It dilutes the acid. Or lowers the concentration. Of acid. What is the color change of the methyl orange indicator at the end point? The sodium hydroxide is taken in flask and sulfuric acid runs from the burette, runs in the conical flask from the burette. So the color change always start from the flask, so it is yellow to orange because we are using methyl orange. It can be red as well as pink. You can write down any color. Now the student does 3 titrations. The diagram shows parts of the parts of the burette with the liquid levels at the beginning and at the end of each experiment. So final reading of burette 1, final 23.7, this is 23.7 and initial is 0.0. The second set of burette 34.9 and initial reading is 10.8. From the third set of the burette 44.5 and 20.2. The answer, subtract the final from initial. This is 23.7, this is 24.1, this is 24.3. Use the so this and 2 and 3 are the best titrations. Use the ticked results to calculate the average volume of the 24.1 plus 24.3. So when it is written in the question to calculate, so just show calculation please. This is equal to 24.2 centimeter cube. Solution M is 0.0500 mole per dm cube sulfuric acid. Calculate the number of moles of sulfuric acid in the average volume of M. This is volume of M. Mole is equal to concentration into volume divided by 1000 because volume is in centimeter cube. The mole is concentration is 0.0500 multiplied by 24.2 divided by 1000, which is equal to 0.00121, or it can be written as 1.21 into 10 raised to 3 centimeter cube. Question number 7. G part is the dilute sulfuric acid reacts with aqueous sodium hydroxide as shown. Sulfuric acid plus sodium hydroxide Na2SO4 plus 2H2O. So calculate the number of moles of sodium hydroxide in 25 centimeter cube of L. So this is equal to by using mole ratio 1:2. So the mole of sulfuric acid is 0.00211, 0.00121 ratio X. So the answer is 0.00242 or 2.42 into 10 raised to minus 3. Calculate the number of moles of sodium hydroxide in 500 centimeter cube of Fel. Mole by using mole ratio volume. 25 centimeter cube contain 0.00242 moles. So what would be the mole if in 500 centimeter cube of the volume ratio X? The answer is 0.0484. So this is the calculate the number of moles in 25 centimeter of cube. So it will be 0.0484. Now calculate the concentration of sodium hydroxide in K. Give answer to 3 significant figures. So this is mole. So concentration is equal to mole over volume divided by multiplied by 1000. So moles are 0.0484 divided by 25 into 1000. So this will be equal to 1.94 mole per dm cube. Between each titration, the student washes a conical flask with water. A second student repeats the experiment but uses L instead of water. To wash, L is sodium hydroxide. Water to wash the conical flask. State and explain whether the second student's titration volume of the dilute sulfuric acid would be larger or smaller or unchanged compared with the first student's volume of dilute sulfuric acid. It would be larger as more sodium hydroxide is in the flask, so larger volume of sulfuric acid will be used. By second student. Question number 4. You are provided with a mixture of copper 2 sulfate, copper 2 carbonate and carbon. Both copper 2 carbonate and carbon are solids. They are both insoluble in water. Copper 2 carbonate reacts with dilute sulfuric acid and form an aqueous solution. Carbon does not react with dissolve in dilute sulfuric acid. So we have CuCO3 plus carbon plus H2SO4. So copper carbonate react with sulfuric acid to form CuSO4, while carbon remain unreactive. So plus water plus CO2. So use this information to plan an experiment to produce a sample of pure carbon from the mixture. You are provided with mixture of copper 2 carbonate and carbon as well as dilute sulfuric acid and distilled water. You have access to the apparatus normally found in a school chemistry lab. No other chemicals are available. Your plan should include details of how to separate the carbon, purify the carbon. Add acids to the mixture in beaker and stir with glass rod. And warm it to ensure. Warm it with the Bunsen burner. To ensure all acid is used up. All carbonate is used. Acid is taken. All copper carbonate is used up as acid is in excess. And to ensure until no more bubbling, filter the solution to remove carbon. Filter the solution to remove carbon as a residue on the filter paper. To wash the residue with distilled water. To purify the carbon. And dry in folds of filter paper. Question number 5. A solid mixture R contains 2 cations and 1 anion. The table shows the test that a student does on R. Complete the table. Identify any gases that are formed in the test. R is dissolved in water. The solution is divided into 3 portions for test B, C and D. Colored solution is formed. So if colored solution is formed, it means R contains transition metal ions. To a portion of the solution from A, aqueous ammonia is added until a change is seen. Result is R contains chromium or iron 2 ions. Green precipitate. An excess of aqueous ammonia is added to the mixture B1. R contain chromium and iron 2 ions. Green precipitate insoluble. The portion to the source Solution A, aqueous sodium hydroxide is added until a change is seen. Green precipitates. An excess of aqueous sodium hydroxide R contains 3 positive ions. Green precipitate dissolves if chromium ions are present. Green precipitate dissolves. The mixture from C2 is warmed and the gas formed is tested with damp red litmus paper. Damp red litmus paper. The gas is ammonia. It means solution contains ammonium ions. Are present. R contains sulfate ions. Aqueous solution contains sulfate ion and acidify the salt with nitric acid, with dilute nitric acid, and then add, followed by barium nitrate. White precipitate are formed, which conforms the sulfate ions in the solution. Question number 6. A student investigates the temperature rise when different masses of magnesium are added to dilute hydrochloric acid. In each experiment, the student pours 100 cm³ of dilute hydrochloric acid into beaker. Places a thermometer into the solid acid. Records the temperature of the acid. Adds a known mass of magnesium to the acid and stirs the mixture. Records the highest temperature reached. Question number 6a. The temperature rise with each mass of magnesium is less than expected. Give one reason for this. Heat lost to the surrounding. State 2 changes that can be made to the operator so that the temperature rise for each mass of magnesium is closer to the expected value for each mass. Insulate the beaker using lead. Second is polystyrene. Polystyrene cup can be used. Polystyrene cup, or using lid on the beaker. Or it can be insulate like this. place cotton wool to insulate this cup. Cotton wool. So next, this is the temperature change. 0.10, it is initial temperature is 20 and this is 22.6, and by subtracting it is 2.6. So for 0.20 it is 25.2, it is 25.2, and the difference is from the initial temperature is 5.2. Second is 27.9 and the difference is 7.9. Third reading is 30.6 and the difference is 10.6, and the last reading is 32.4 and the difference is 12.4. What evidence in the table shows that the reaction is exothermic? As the temperature rises, as the temperature rises, so draw the graph. I have drawn to save the time earlier. So 0. This is so, and this one. Temperature rise and mass of magnesium. Use your graph to answer the questions. In each case, assume that magnesium is added to 100 centimeter cube of dilute hydrochloric acid at 20 degrees centigrade. What is the temperature rise when 0.35 gram of magnesium is added? 0.35 gram. This is equal to almost 9 or 9.2. 9.2. What is the highest temperature when 0.15 gram of magnesium is added? 0.15 gram is added. This is about 3.9. So this is 3.9 and the initial temperature is 20. So 20 plus 0.3.9, it will be 23.9 degrees centigrade. What mass of magnesium is used to give highest temperature of 26 degrees centigrade? Highest temperature of 26 degrees centigrade. mass of highest temperature the extrapolate what mass of magnesium is used to give what mass of magnesium is used to give a highest temperature of 26 degrees centigrade. So this is about 26 degrees centigrade. This is 0.23 gram. 0.23 gram. What is the minimum mass of magnesium that react with all of the hydrochloric acid? This is the this is about 0. Nearly about 0.45. This is 0.504. So over here, so I draw this pen. This is about from here, this line is correct. It's nearly about 0.47. 0.47 gram. So over here 26 degrees centigrade. 26, if 26 and initial temperature is 20 degrees centigrade, this will be equal to 6 degrees centigrade, 20 degrees centigrade, 6 degrees centigrade. So at 6 degrees centigrade, this is 0.23 gram. 6 degrees centigrade, it is 0.23 gram. Now it is hopeful it is correct now. Oh sorry, it is understood now. Use your answer E4 to calculate the number of moles of magnesium that reacts with 100 centimeter cube of dilute hydrochloric acid. Your answer for 0.47 gram to calculate the number of moles. Mole is equal to 0.475 divided by 24 AR of the magnesium. So this is equal to 0.01979, that is approximately 0.0198. This is 0.0198 approximately. Now calculate the concentration. in mole per dm cube of hydrochloric acid. So mole ratio is 1:2, and mole of magnesium is 0.0198 ratio x. Cross multiply, and it is equal to 0.39. So this is mole. Let's calculate. Zero point 198 into 2 is equal to 0.396. So this is mole and dissolved in 100 centimeter cube of water. So concentration is equal to 0.396 divided by volume, 100/1000. So this is equal to 100 over divided by 100 divided by 1000 is equal to 0.1. So 0.396 divided by 0.1 is equal to 3.96 is the mole per dm cube. Okay, thank you. Please subscribe and like this channel. Like this video if you like this, and if you have any issues, problems, any queries, can ask me in comment box.